Welcome hackers. In this video, we're going to be assembling the MakeItHackin DEF 29 badge. This video is sponsored by JLC PCB, where you can get custom PCBs for $2, and this is where I got the PCBs for my project. All right, so now we're going to unbox the kit and see what's inside. All right, so let's open the box. We got the bag in here. Okay, put the box off to the side. Okay, we have a packing list, as well as the GitHub link and QR code. You can scan that or type the address into your computer, get much more information that you need. Here, this is what we have our screen and battery pack attached to. There's legs that kind of poke through the styrofoam, so just be careful. That's why they're in there. Okay, we have this component breakout right here. This is most of the components you need. We have our lanyard. In a pink bag will be the ATtiny85. This has been pre-programmed. I was able to pre-program this. Really excited about that part, but we'll put this off to the side. We have a couple stickers. MakeItHackin stickers. This one was one that I made for the DEF CON sticker contest. I got second place. And then this is the general MakeItHackin sticker. So feel free to put these on your laptop or anything else. We have our batteries. And last but not least, the circuit board. This is the MakeItHackin DEF 29 circuit board. All right. So this is basically everything that you need. When deciding how to put these components into the kit, I thought, how should I do this? Because I know if I was making this kit, I would want it kind of easily done. So I broke out everything with its corresponding name that I named it in the circuit software. Now, it might not be the best naming convention because I kind of just used the default for some of it, but I labeled them here. And if you go to the GitHub link with all the instructions, you'll see that everything kind of corresponds to these names here. So that's how everything is labeled. So that's all the components that you have. You'll need some tools, okay? So what tools will you need? You will need some diagonal cutters. You'll need some tweezers. You'll need some solder paste and a way to apply that solder paste onto the circuit board. If you have a small sort of tip like this, then you could theoretically do it with that. Some of the pads are small, so you might have trouble more than others. Or you can sometimes apply the solder paste to some tweezers and then apply it like that. However you normally do it. This kit is not for beginners. It's for people who already have surface mount experience. So however you do it, I'm going to be using a stencil, doing it the easy way. If you want to make a stencil, feel free. The files are going to be in the GitHub link so you can get one made. You also might want some flux if you need it, if you do that sort of thing. To melt the solder, you have basically three options. You can use a soldering iron, you can use a hot air gun, that's a little bit better, or you can use a toaster oven. Remember, if you do a toaster oven, don't use that for food, only use it for your circuit board stuff because it gets really nasty. I'm gonna be using the toaster oven method. All right, so let's clear off these components and let's get started. All right, so the first thing I'm gonna do is clean the circuit board. I used 90% isopropyl alcohol and a rag. Now again, I'm gonna do it the easy way, and I already have a stencil for this thing, so this might differ depending on how you do it. Remember, all you're gonna do is place solder paste on all the different pads, but the stencil makes it really, really easy. The thing that I have rigged up here is a jig for doing the stencil. So since the circuit board is 1.6 millimeters thick, I put other 1.6 millimeter circuit boards around it to kind of hold it. Then I place the stencil on top. Okay, after I get it lined up, I put a piece of tape on top. That kind of acts like a hinge. I can bring it up and lay it down, right? The next thing I do is grab my solder paste and I put it on the stencil all around the different holes. So just put some up here, down here. So after I have the solder paste on there, then I take a card and I use it as a squeegee and get it in all the different holes. And it's done. Lift up the stencil and we take out the board and all the solder paste has been applied exactly where it needs to go. That's the awesome thing about stencils. You can also get stencils from JLC PCB, and if you're doing more than one, I highly recommend that you get a stencil. It's just $7 and it makes life so much easier. So after I'm done with the stencil, I clean it with isopropyl alcohol. Since everyone might not have a stencil, I'm going to show you how I do it if I didn't have one. So I could just apply it onto a pad, just using the tip kind of like that. So that's one way. There's way too much solder paste on there, so I need to pick it back up. The other way you can do it is get some sort of small tool, and for example, I'll apply some on this card. And I can use this tool, get some off the card, and then place it onto the pad like that. There's probably other ways to do this too. This is just one of the ways. You see how slow this is? This is why I highly recommend that you use a stencil whenever you can. Just remember that the smallest component on here is going to be the light sensor, and it is kind of a pain to deal with, but if you can do that light sensor, you can do anything. So that's how you would apply solder paste if you didn't have a stencil. Again, there might be a little bit too much solder paste on there, so you can use your tool to kind of move it around or take some off and that sort of deal. So now that you have the solder paste on the circuit board, we're going to be placing the surface mount components on top of the solder paste. So for this, you will need your circuit board with the solder paste applied. You will also need this component sheet. We're going to do all these surface mount components first. There's a couple components here that are through hole. We're going to wait for those later. There's not any particular order that you need to do this in. I'm just going to start with the Neopixels and move my way down. So this is held on by Scotch tape. Just kind of use your tweezers to get it off. All right, so here's the Neopixels. There are 4 of them. The polarity marking for the Neopixels is the little triangle in one of the corners, and that goes on the dot that you see here. That's the polarity marking right there, that little triangle. And on the circuit board, the polarity marking is that dot right there. So we take our Neopixel, and we'll start like that. You just kind of put it right on top, press it down a little bit. Don't make it move a whole lot. All right, and there we have the Neopixels. Next is going to be the buttons. There's the same button for both used as reset and the menu button. All right, next we have the switch. The switch can go either way. Whether you want the switch to sort of be on the right hand or the left hand, it really doesn't matter. It'll still work. The switch has a couple little knobs in it, and they go into the holes that are on the circuit board. All right, next we have C1 and C2. These are the 10 microfarad capacitors. With these really small components, just be careful that you don't lose them. All right, so the first 10 microfarad capacitor we're going to put right here, and the second one we're going to put up here. All right, next we have the 1 microfarad capacitor, which is C11, and C11 goes right up here at the top. All right, next we have R1 and R24. Those are 470 ohm resistors. Remember, these surface mount resistors are not polarized, so they can be either way. Okay, the first one we're going to put up here at the top by the first Neopixel. The second one is going to be down at the bottom near the power LED. All right, next is R7. R7 is the 10 kilo ohm resistor that goes next to the light sensor. Next is R18. R18 is the 330 ohm resistor. This connects to the SAO port. It's technically not needed, but it's recommended. And finally, we have R26. This is the 100 kilo ohm resistor tied to the voltage regulator. All right, so that's the left side of the components. Now we move to the right side, and the first component is our diode D4. So this is how you're going to be placing it on the board. The marking is going to be on the left-hand side, and the numbers and letters should be readable. And it goes right there. Next, we have our voltage regulator, which is U3. This is also polarized, but there's 3 legs on one side, 2 on the other, so it's easy to figure out. Goes right here. All right, next is U2, which is our light sensor. This is the most problematic part in the whole thing, so make sure you do this very carefully and get it right. All right, so the way that this light sensor should be facing is with the black dot towards the bottom half. It's almost at center, but it's just a little bit more on one half, so make sure that that half is on the bottom half. There's also a polarity marking on the back of it. It should look like a little bump. That is going to be towards the bottom. So when we're talking about the bottom, this is the bottom. Make sure that the black dot is towards the bottom half, and if you were to turn it over, the bump is on the bottom. All right, next we have the power LED. The power LED is polarized. If you look on the top, there should be a very faint green dot on one of the halves. That is the ground side. We want that facing the bottom of the board. On the back of surface mount LEDs, there should also be a green marking. However, it is a little bit different. It points towards the ground. So this one's pretty easy to figure out because it's a triangle. It's pointing towards the bottom, so we want it faced like that. Other ones might have some other sort of marking. This one's gonna be a triangle. All right, the last surface mount component is going to be the ATtiny85 microcontroller. This one has already been pre-programmed. It's in this pink bag. The ATtiny85 has a polarity marking. It's that little dot in the upper left-hand corner, and that's how it's gonna be facing on our board. All right, so that is all of the surface mount components. Now would be the time that you heat it up, and I recommend either using a hot air station if you have one, or better yet, a toaster oven. So I'm gonna show you how I do the toaster oven. All right, so this is the toaster oven that I use. I will put the model number in the description, but it's a Cuisinart, and I'm gonna put it on convection bake. And the temperature could depend on the solder paste that you're using. I put mine at 425 degrees Fahrenheit. I hit start, and it takes about 5 minutes to heat up. Okay, so then I very carefully take my board with all of its components, and I move it over to the tray, and I put it on like that. All right, temperature is ready. So what I do is I open up this, put the tray in very carefully so the components don't slide around. And I wait for 6 minutes. All right, time is up. For me, I just hit stop or turn it off, and then I open up the door. Everything is still really hot and the components can move around, so I just kind of leave it like that. Once it's done cooling down, I will take it out. So I do recommend the toaster oven. If you don't have one dedicated to surface mount soldering, then I would do hot air, which I will demonstrate. And if you don't have one of those, you can do it with a soldering iron, but definitely recommended that you do it with hot air or a toaster oven. All right, so first I need to apply the solder paste. So I'm gonna see if I can get it with this syringe that's just kind of already on the solder paste. You don't really need a whole lot. We're just gonna kind of do it like that. I'm gonna clean it up a little bit with this tool here, just kind of push it around the pad a little bit. Definitely not as nice as using a stencil. It's possible that you could get some bridging, so just be careful. But the good thing about surface mount soldering is that it wicks up. I'm gonna now place the resistors on there. So we have one here. And again, this is just a demo board. It's not part of the project. I'm just gonna show you how to heat it up using a soldering iron and then hot air. For the soldering iron, I use a Weller, and I'm gonna switch out this tip to the nice pointy one since I'm doing surface mount soldering. Don't grab your soldering iron while it's hot, obviously. Okay, we're gonna turn that on and let it heat up. All right, now the soldering iron is heated up. I set mine to 650 degrees Fahrenheit. All right, so I'm just going to try and touch the pad as much as possible. Just kind of let it heat up. Okay. And now I'm gonna let that cool down a little bit. Don't have to wait too long, but just wait a little bit, and then I'll touch the other side. You might wanna press down with some tweezers. And that is how you can use a soldering iron to do surface mount soldering, but not recommended. The other way to do it is to use a hot air station. This one is a generic one that I bought off Amazon. I think it's probably like 50 bucks, something like that. And let's see, I have it set to 387 degrees. And with the air pressure, I have mine set to 3. You don't want to blow the components all over the place. And here we go, this is what this looks like. So you'll see that the solder starts melting. You can kind of approach it from different angles, get heated up, and you'll see the solder turn silver, and that's when it's good to go. This other one kind of moved a little bit, so you may want to just kind of, fix it while it's hot, and there we go. And that's how you can use the hot air station. All right, so now the badge is cooled down, let's take a look at it. And this is the reason why I love the toaster oven. Look at these soldering joints. They are just so nice and clean. And just taking a look at this, I don't think I have to do any rework. This is all with the toaster oven and stencil. The stencil helps to kind of keep it really neat. If you did need to fix any of this stuff, I would recommend that you use some flux, pick up the part and put it back down. Remember that the light sensor is going to be the most painful part. So as long as you put it on right and it looks good here, you should be fine. All right, so now that we have all of our surface mount components attached to the board, we're now going to solder on the through-hole components. So the first component that we're going to start with is the screen. I've tested these before I sent them out to you, but just to show you how I tested it, I placed it into this little board like this. Just make sure it turns on. These are really a pain to solder. That's why I've tested them beforehand, because if you solder it on and then it doesn't work, then it's kind of a pain to desolder. To help align the screen, I've made this 3D printed part. It's not included in the kit, but I do have the file available on the GitHub if you want to print it. I really only designed the part because it's a little annoying to align the screen, and I was doing a lot of these for the fully assembled badges, so I just have it anyway. But let me kind of show you what I'm talking about. When you put in the screen, it kind of doesn't set even, so it does have some flexibility to move up and down that way as well as this way. So you can just either hold on to it really still and then just do one pin at a time, but you could also print this out and hold it for you. So if you did print this out, you can put this part on here and then you slide it over the screen like this, and it will hold the screen pretty much everywhere that it can flex, and then you can just work on the soldering like that. The solder that I use is 0.6 millimeters in diameter. It's a 63-37 ratio, and I love it. I got it from Amazon. All right, so I don't recommend starting with the bottom one. The bottom one with the ground takes a little more heat, so I'm just gonna start with the top one. Now would be a good time to check and make sure everything is good. If it's not, or you wanna realign it, this is the best time to do that. Only do one pin and then make your adjustments. But everything looks fine, so I'm gonna go ahead and move on to the other ones. I don't have a fume extractor set up. Sometimes I use a little mini USB fan, but since I'm not doing that much soldering, I'm just gonna blow it away. And that is how the screen should look when you're done with it. All right, next we're gonna grab one of our components from here. It is the $3 component. That is our Sao connector. That goes down here, and the little bump is gonna be on top. Put it just like that, and this again can kind of flex a little bit, so turn it over and just do one pin first, and then you can align it, realign it if you need to. This one looks pretty square. So I'm just going to go ahead and continue to solder. Boom, and that is the Sao connector. The last piece is our battery pack. It comes attached to the foam, so we just pull this out. Just be careful, it's got these really long legs. Those legs go in right here, okay? And I recommend doing this one first, the one on the left. That is the positive side. The ground side is just a little bit harder because it's got more metal that it's touching. So let's go ahead and do the positive one first. Okay, we're gonna check the back and look at the alignment. Alignment looks fine. You can fix it if you need to. And then we do the ground. This ground one is a little bit tough. There's just so much metal, so it might take longer for the solder to kind of drop on the pad, but it should look something like this. Okay, now we have these extra legs. What are you gonna do with these really long legs? You get your diagonal cutters and we're gonna cut them off. So make sure you're wearing eye protection when you do this. All right, do I look cool now? All right, let's get this. So I just kind of grab on here. I grab one of the legs while I clip it so it doesn't go flying, okay? And then I do that for the other one. Okay, now I could leave it like this, but these are a little bit, not sharp really, but they don't really look nice. So I just put a little bit more solder on it to kind of make it nice and round, so there's not any sharp edges. We're almost done. All right, so on the back of your component sheet, we have the security tags. There's the 8.2 megahertz and the 58 kilohertz. So let's just grab those. All right, so we're gonna peel off the 8.2 megahertz, place that on, and then the 58 kilohertz. Remember, these are active security tags, so please do not take them into a store that would set them off. Okay, let me place this one, boom, like that. All right, now let's grab our batteries. Okay, let's hope this turns on. These have been pre-programmed, so it just should start working. If there's an issue, you can try and reprogram it, and here we go. Boom. Yay, it works. All right, let's just test everything. So it says press button to test components. We got our light sensor value, that's good. When we cover it up, it moves. If you notice that the light sensor value is reading really low when it's bright, or you don't get numbers above like 100 when it's bright, most likely you have it turned 180 degrees. If you do have it turned 180 degrees, and remember there's the black mark that should be on the bottom, I recommend that you use flux to try and get that light sensor off the board, because it is so small that if you try and desolder it, it's really hard to desolder if you don't have flux and keep the component intact. All right, next we have our night light mode. So press that and looks like all the lights are coming on. That's good. And then next we go into our demo mode. Shows the loading screen as well as these LEDs. So yeah, everything works. That's great. Finally, we put on the lanyard and we are good to go. You should have one piece left in your kit. It should be this tiny 2x3 female connector. It goes up here in the programming port. That is if you want to reprogram this, and you really don't even technically need this. It just makes it a little bit easier depending on your situation. So this is an optional thing. If you want it, you can just kind of put pogo pins or whatever into the programming port, or put the male pins in there and just kind of like bend them a little bit. So this is optional. All right, thanks everyone for supporting this project. I really appreciate it. Let me know if you had any problems putting the kit together. Let me know if there's like processes or procedures that you've done that I haven't done that are awesome. I'm really looking forward to next year's DEF CON and seeing what badge I come up with then. If you have any suggestions, let me know in the comments below.